How will you plot the complex number plus pi on the argand plane? Assume A and P are both positive. We will move a unit right on the red real axis and P unit up to get the point P. We can call it a point P and let us say that a point 0. Now just focus on a point P. If you want to ask your friend to plot point P, now how would you do if your friend just has an empty graph in front of her and you want to ask her to plot point P? Let us move this graph to the left and have an empty one on the right. So one thing you could tell your friend is move a unit to the right and P units upward and you will get point P. Is there any other way in which you can ask to plot this point? Let me give you a hint. I joined points 0 and P. I will call this angle theta and assume this length is r. This was a big hint what you can tell your friend such that plots point P correctly. Well, you can tell your friend two things. First, the distance of points P from the original, and second, the angle at which length OP is placed from the positive side of the horizontal axis. So if you tell that point P is our units along at angle of the degree from the positive x-axis, will be able to precisely plot point P. So this was another way to present point P. You can either give A and P or R and theta. In either case, will be able to plot point P. These things you see on the right is the polar representation of complex number. Nothing different and nothing fancy. It is the same concept. They are just using different parameters to represent point. If you are looking at this right triangle, this length is A, this length is B, this length is our angle POA, is theta, and this angle is 90 degrees. Now let us just focus on this triangle and nothing else. Let me ask you a simple question. Can you tell me the lengths of R terms of A and B? Come on, you should be able to answer this. At this right triangle, we can use the theorem to Fascicles theorem to find our R. Square will equal square plus P square. The square of the height is equal to the sum of the squares of other two sides. Taking the square root on both sides, we get the value of R as the root of square plus P square. This is nothing but the models of the complex number said. We had covered this in one of our video of the complex number Z is equal to plus Pi. Then the models of this complex number set the square root of square plus P square. It is also known as the absolute value of the complex number. What is the theta then? It is called the argument of Z, which can also be written like this. Now that we know how to represent R in terms of A and P, can you try and drive theta in terms of A and P? Let me give you a hint. Use trigonometric identities in this triangle. Do you remember the code we use for the three basic functions? Trigonometry? Yes, it is. Since sine is opposite or cos is over and tan is opposite over, so sine theta can be written as B over R. We get the value of B as R. Sine theta cos theta can be written as A over R, which tell us that R. Cos theta, now we have and but we still didn't have theta in terms of A and P. But are these two enough to give us that? Yes. All we need to do is divide it by P by A. R gets cancelled and we get B over A as sine theta over cosine theta. And what sine over cosine? It is tan. tan theta will equal B over should be able to answer this. As this is the right triangle, we can use the Fascicles Theorem to find our R. Square will equal A square plus B square. The square of the is equal to the sum of the squares of other two sides, taken the square root on both sides. We get the value of R as the root of square plus B square. This is a nothing, but the models of the complex number said we had covered this in one of our video of the complex number. Z is equal to the A plus Pi. Then the models of this complex number set is the square root of square plus B square. It is also known as the absolute value of the complex number. What is the theta then? It is called the argument of Z, which can also be written like this now that we know how to represent R in terms of A and P. Can you try and try the theta in terms of A and P? Let me give you sine theta can be written as B over R. We get the value of P as R sine theta. Cosine theta can be written as over R, which tell us that A is R cosine theta. Now we have A and P in terms of R and theta, but we still don't have theta in terms of A and P. But are these two enough to give us that? Yes, all we need to do is divide P by A. R gets cancelled and we get B over A as sine theta over cosine theta. And what is the since over cosine? It is tan. Tan theta will equal P over A. Hence, theta will equal tan inverse of B over A. That is theta in terms of A and B. With this, we have successfully represented R and theta in terms of A and P. So if we have the real and imaginary part of the complex number, we can represent it in the polar forms as well. In the process of doing this, we have also derived a couple of other relations. A is R cosine theta and P is R sine theta. So the complex number A plus Pi can also be written as R cosine theta plus R sine theta times I, as R is common. To both terms, we can write it as R times cosine theta plus I. Since theta sine theta, this is the polar from the complex number. R is the modulus of Z and theta is the argument of Z. So if we are given A and B, we can get the polar coordinates R and theta, and if we are given the polar coordinates, we can get the value of real and imaginary parts. Why do we need the polar form? We all use this concept locating a point V specified direction along with the distance from the center point. For instance, while making places on a map, we see that particular city is 200 kilometers north, so R is 200 and theta is 45 degrees. I also want to show you a beautiful way to have a polar representation graph. This is how you can imagine it is this 1 unit radius circle, this is the 2 units radius circle, and these are angles marked at interval of 15 degrees. So if R is 3 units and theta is 45 degrees, the point will lie here. If R is 2 units and theta is 135 degrees, the point will lie here. If r is 4 units and theta is 315 degrees, the point will lie here. You may not see this diagram in the textbooks, but it is really good way to understand the polar representations